house and took the keys, and I was like, hey.
I walked into the house and she's like, stop. Why? I'm like, oh. She's like, yeah, I almost just fell out my basement stairs.
I don't know, how you take 2 steps into the house. So the house we're talking about is formatted really weird. So you take 2 steps in and then there's stairs directly down.
Wow, sounds dangerous
And you turn the
actually.
microwave on and the lights flicker and the Wi-Fi goes out. It's a good time.
Sounds well made. Alrighty friends, so hopefully you got my email. How many folks actually looked at the solution of number 4 besides? Yes? Yes.
I kind of
Yay,
did,
yay.
but I had to.
I'm so proud of it.
I know it was a lot, but I didn't have much time to like
It's
go
okay.
through it.
It's okay. It's
It
cool.
was so cool though.
It was cool. It was cool how it worked out.
Well,
So
not cool.
one,
It was a lot.
it was a lot. It was, no, but in the end, I was so happy. It was like, I was working on this. My wife went to bed early on Friday. I was just like hanging out. I was like, I'm gonna get that damn problem knocked out. And I did. So it was really exciting. Hot Friday night. So one thing I do want to comment on is that process, and then I want to talk about it a little bit, and then we can work on the web work or finish it up or take questions on it, whatever you got going on. So the process, the way I showed you, right? We've got this, and you start on one side, right? And you assume this, and then you integrate, and you get this, and you put your g of y there, and then you differentiate with respect to the other variable. Here it's y. And this is going to get gnarly looking. That's cool, actually. And then the way I was telling everyone to do this, and it works for the most part, this way I always did it, but to like look at n, so compare this to n and figure out what needs to be, I think we call it c, but hey, it's g, whatever, and figure out that constant. And then Kitra was talking about how she approached this problem, and what she did was actually set g prime equal to n minus this, or c prime, right? I guess it's c prime for us. And then just work this way. This is how I busted that problem open, because there was some really weird algebra that was in there that was not at all clear. I mean, you had this nasty expression with x's and y's, and there was no obvious fact. There was no way to assume, oh, that just depends on y solely. You know, it's not just some function of x and y simultaneously. So I think this is probably a really good approach. I don't think you can go wrong with this. So really, really nice. This is what solved it for me. So that's all I had to say about that. But what I also wanted to say, I wanted to put some of this stuff we've been doing to use. A little bit of application time. So just some simple physics applications for us, and not just physics, like population study. I've got some examples for us. So let's just do some applications. I'm thinking exam 1 is coming up in like a couple of weeks, like possibly a week from this Wednesday, possibly next Wednesday, I guess that's another way to say it, or the Monday after that, so like 2 weeks from today. I'll know on Wednesday. I won't like decide on Monday if the exam's on Wednesday. I'll let you know on Wednesday. But the reason I'm thinking of that is I will probably give you a take-home component to it, because I'm going to want you to do an application, and that you just like you can't do anything meaningful in an exam for an application, nothing interesting. So I'll give you like a take-home part. You bring that in. The rest of the exam will be pretty straightforward. What's up, Chris?
I said I agree with that.
You agree with that? Awesome. Yeah. So let's talk about radioactive decay, which was literally the first thing I talked about in this class, I think, wasn't it? And we had a little block. Let's make it an actual 3D block. We had a little block of strontium. I'm sure there's some number that goes with that. Somebody could know, but I don't freaking know. But it's radioactive. and it had.
I don't know.
Why have I been carrying this in my pocket? Oh my God! So when I got early on, when I got here, Dr. Gray had just come here. We had lost this old physicist that was here. Norb was his name. Really interesting name. And he had collected the craziest shit in that basement of the science building. Like that used to be math and physics only down there. And
The science building?
The science building, yeah.
Oh, that was math.
That was math
Oh, I didn't know
originally.
that.
Yeah. And we lived in like this 70s suite, looked like the Brady Bunch. You know, it was like wood paneling and terrible carpet and stuff. So anyway, when they were cleaning that out, when Dr. Gray was cleaning that out, they found a block of radioactive bar in his desk.
Yeah, I heard about this.
What?
Did you hear about this?
Wait, he passed away, right?
Yeah, he was pretty. You know,
Was it from
we don't know if
cancer?
it had to do with the.
No, I'm
radioactive
serious.
bar.
That's the story I've heard. I heard he passed away from cancer.
That is true.
That-
You know,
see? Coincidental? I think not.
It didn't help. It definitely didn't help. Yeah. So.
Didn't they find an open container of mercury that had also
Probably
evaporated?
with a big ladle in it, so
Yeah.
you could just like get a cup of it or something. I don't know.
This man said I
Yeah.
think like the most toxic materials.
Yes. Yes. All right. So let's say I've got this block of strontium. I understand it's radioactive, and so if A of t is the amount at time t in grams, then we came up with this equation. Let's just talk about it again. dA dt is proportional to the amount of stuff I have. Do you remember how that kind of worked? I talked about a little, if I had 100 grams on day 0, and then I went 28.8 years, and then 28.8 years later I've got 50 grams. So that's 28.8. In another 28.8 years, I have 25 grams, and so on and so forth. And so this never really goes to 0. I guess it just kind of dissipates away until there's nothing of essence left. But this halving process keeps going on forever. But look at the rate of change here. So the amount of A, the change in A over the change in time here is 50 over 28.8. The amount, the rate of change here in this interval is half that. It's 25 over 28.8, because we lost 25 grams, and actually I guess negative is probably even better there, right? But notice how the rate of change is changing. Here it's whatever this number is, not quite 2. And here it's less than 1. But this number is proportional, look at the number on top, it's proportional to how much I have at any particular moment. And so we took this idea that the average rate of change is proportional to the amount that we have at a particular time, and then we let delta t go to 0, and what we got was this equation, dA dt equals Ka. That was the rough process, the thought process behind it. That the rate of change is is directly proportional to the amount you have. So let's say I have this, let's just do the 100 grams. So we have 100 grams to start. How much, now I'm not gonna ask some, like I know how much I'll have left in 28.8 years. How much left in 10 years? So this will be right up our alley, DiffEQ folk. So, we have an initial value problem. We have dA dt equals Ka. I don't know what K is. Isn't that interesting? And I do know that A at time 0 is 100. So, step 1 is solve that differential equation. Could you solve that for me, please? I know you can. This is like cake compared to the shit I give you to do all the time. Solve that for A, please. Get an explicit A of t equals, because now you have the power. just get the general solution. You'll have k still in there. Don't worry about that. You'll have a k and a c in there when you get done. You've already knocked it out. So you did it right. And you did?
Yeah.
You rocked it out? Yeah. Look back here, everybody rocking this? Oh yeah, look at this. We're pros. We're professionals at this now. We don't receive a salary of any sort.
I mean, like that.
So the k is not a
Wow.
Case
That's like 4 full steps.
Yeah, yeah.
Integrate with, so back t, because it's a constant.
Yeah, don't be careful with that k, because that is just an arbitrary constant. But we separate this thing, right? Like so. I would keep the k over here, you can bring it down, but that seems like a pain. Integrate both sides. Nice and painless. Then solve for a, and hopefully, if I make this move, this makes perfect sense to you, that is now the case. You've seen this so many times, right? This little move right here. So, cool. So we've got two unknowns in here. Now, if I put in a at 0 equals 100, I'm gonna get c equals 100. So let's just take a look at that really quick. So a at 0 equals 100 means this equation becomes 100 equals c times e to the 0. C is 100. So the c is actually your initial amount. If we wanted, we could redo this whole thing and put a sub 0 here if we wanted, and give someone a formula. But what about that k? So right now I've got this. Any idea? So how can I find k? What else do I know? I know the half-life. Indeed. So I'm going to use that half-life info to get that k. So use half-life to find k. And if we wanted, we could do this in general, come up with a formula and put it in the textbook. We could just call the half-life T, capital T or something, and then work out this whole formula and look like geniuses. And we, like relative to we're in the upper echelons of human knowledge here in this class. You may not feel like it sometimes, but we are. So we know that half of the initial amount, so 50 grams is left after 28.8 years. So what I'm doing is I'm just putting 50 in on this side and 28.8 in on the t. Now I'm going to solve for k. So to do that, I first have to isolate the e. So that's going to be 1/2 equals e to the k. 28.8. Oh, like a half-life, you mean? Yeah. A half-life right there. Take the log of both sides. K is 1/28.8 times natural log of 1/2. Notice that this is a negative number here. It's just hidden. So let's unhide it. So this is 1/28.8 natural log of 2 to the -1. And that's -1/28.8 natural log of 2. So that's my k. And I'm going to put that in here. And I'm going to show you a couple other algebra tricks here while we're chilling. So this is a equals 100 e to the now found 1/28.8 times log 2 times t. There's our formula. And so now we can answer that question, how much is left in 10 years? I just slap a 10 in here. I do want to show you that this can be made a little prettier though. And so I'm going to do that. So this is 100 times, this is great. There's nothing wrong with this formula. It's just my weird math desires are kicking in here. This is e to the natural log of 2 to the negative t over 28.8. I'm just rearranging some stuff, using some properties of exponents. And so what's e to the natural log of 2? 2. That's just 2. So this is 100 times 2 to the negative t over 28.8. And then for the great reveal, this is 100. That's just 1/2 times positive t over 28.8. Isn't that cool? Because then it shows like half-life is in here, right? And then when t equals 28.8, I just got 100 times 1/2. Pretty cool. That's beauty. That is true beauty. So let's answer our final problem then. So a at 10 is equal to 100 times, this is probably, I don't know, somebody got a calculator? I have no idea what the answer is here, since all this shit was made up except the half-life. You can put it into any of these for us. It's like 70, feeling like it's gonna be like a 70 grams.
78.6.
78.6. 78.6 grams. There we go. Cool. We did that from like first principles, right? Now we know how to do that. We took an idea based on an observation. We produced solid results, which is really cool, really beautiful. And this is like our simplest technique, right? Literally the simplest thing we know how to do in here. We also know that can be a challenging thing. Is there any questions on any of this? Because that's like, yeah, Chris.
This might be stupid, but how did you get the dA dt, or dA over dt equals Ka?
So we looked at this observation that the average rate of change was proportional. So here's the constant of proportionality, proportional to the amount I had at that start of that period.
Okay.
And then some little hand waving going on here. We let delta t go to 0
Okay.
and crossed our fingers.
Yeah. Okay.
Yeah.
That makes sense.
Yeah. Anything else? Yeah? Cool. I want to do one more. Then I think on Wednesday I'll probably come in and do something really fun, bless you, or something there. So I raced from the wrong side. I hope, I'll babble while I'm doing this. I hope some of you are gonna come by the math office and have some snacks and do some problems that I spent a lot of time on this weekend about E. All about E. Some of them I don't even know how to do. It's like, well, that looks cool. I think there's really only one I have no idea how to do. Not well anyway. I got some rough ideas. Okay, so let's do one more thing here. Let's talk about logistic growth. A really good thing to know about in general. And how many folks have seen logistic growth somewhere? In like a ecology or a bio class? Yeah, it's that kind of thing. So it's one of our simplest models of growth that we have, of growth that's somewhat reasonable. So let's talk about growth in general. So unchecked growth, if I let A of t equal, how about P of t equals the population size at time t, you pick your favorite time scale. I could say that the rate of change, so dp dt, is directly proportional to the current population. Let's think about why that would be, because it's exactly the same thing as radioactive decay run backwards. Same thing. Let's think about spread of a rumor. You've got some secret. You tell someone, and you really hope that someone keeps it more secret than you have. For some reason you couldn't keep the secret, but you're positive that they can.
Rule number one, never tell anyone anything.
Yeah, exactly. This is like, anybody watch Survivor?
Yeah.
Survivor. This is how people blow it. They tell people they have the idol, or like some kind of, you know.
A clue or secret?
Yeah, see, clear secret, like an idiot, and they trust this person, and then it's all over. So this person doesn't, and they tell two people, and there used to be an old TV ad with, and they told two people, and they told 2 people, and so on and so on. So you can think of this as a rumor, you can think of this as mitosis of a cell, right? Just splitting.
Can you teach bio next year?
Well, this would be the end of class. It's right there after that. Because I was like looking at your face and I was like, shit, did I use the right word? I don't know, mitosis, is that right?
You're right.
Okay, all right. Cool. So let's say this happens over the same period of time. So this is like just some time unit here, but you can see that over that interval of time, the amount of change in the number of people who know it is drastically increasing. In fact, here, the change in P over the change in time, if we think this is delta T right here, is actually directly equal to twice. It's twice the current number. So something like that almost is kicking in here. Does this make sense vaguely? Yeah. So the rate of change of growth, it looks like radioactive decay. But this is unchecked and this is somewhat unrealistic because everything has a lifespan, everything. And everything has a finite amount of resources in it. So if you're doing some sort of bacterial growth in a petri dish, eventually they're going to run out of, they're going to be competing for resources, it's going to be overcrowded, there's just simply not enough room, all sorts of things are going to limit that population. So there's a thing called carrying capacity, let's call it K. So this is the carrying capacity of the population at hand. So I'll just make a little note here that this is unchecked growth, which is just not the way of the world. This next one's also not the way of the world, but it's a hell of a lot closer to this. So, even the universe is expanding, but that's gonna stop probably, right? At some point, it's gonna run out of energy or it's gonna like come back, or I don't know what they think these days. They change it all the time. Let's think about a different model. So I'm gonna make this dp/dt, and I haven't really done anything like this, what I'm about to show you here, but it leads into something else I wanna talk about on Wednesday, which is really cool. So let's think about how a realistic way that the population rate of growth could change dependent upon the population. So first off, I'm going to not put K out here because I can't go past K. There's nothing past there for me. That's the carrying capacity. That's the most the population can be given circumstances, whatever those are. And let's think here. Now, if there's no one in the population, the growth rate is 0. If we have reached carrying capacity, the growth rate is going to be 0 because there can be no more growth. But in between here, things are going to pick up for a while. So we're going to see the growth rate as more, look at this. It's kind of like the unchecked growth for a while. As more critters are born, they can make more critters on the next wave of critterdom or whatever. So this is going to go up. But at some point, maybe halfway, maybe somewhere else, but for this model it's going to be halfway, resources start drying up. And so people start dying off, critters start dying off. I'll make it critters, not people. Make it not too sad or anything for us personally. Critters are still sad. But we might see something like this. A slow decline after we start to reach kind of like this midpoint in resources, and then there's just less and less room, so the growth slows, critters die, things get used up. Does this seem reasonable?
It wouldn't plateau.
Well, the growth rate wouldn't.
Oh.
So yeah, you're right about that, Chris. So like the population
I'm
would
thinking about
plateau.
just the number.
Uh-huh.
Yeah.
It's
Okay.
good. So this is a really different way to think about things. Yeah, did you have a question, Kendra?
I was wondering if this is something that you might have shown us last semester with
It's related to that, but it's
Okay.
not that.
No, I was just excited.
No, that's good. No, that is exciting, but that's not what this is. But I like that you remember that. So this is actually called a phase diagram because it's relating, notice there's no time in here at all. There's no time, it's relating the rate of change to the current state. It's a very different way to see the information. But using this, we can now come up with a differential equation. So let's say P dot, the rate of change. What do you think? I don't know, give me, what's the simplest shape that could be? Give me a shape. What is it? What is that shape? Here's a quiz. We're like juniors and seniors here in college. What shape is that?
Parabola.
Parabola. Yeah, that's a parabola. Exactly. That's a parabola. And it's got intercepts at 0 and k, right? It's got intercepts at 0 and k. So we could say, let's put a constant of proportionality because we don't know how high the vertex is. And it opens downward, so I need a negative p squared in there, right? Now remember, this is going to be in p. This is like my y. So p dot is my y. P is going to be my x, if we're thinking x, y axes kind of stuff. So here I'm going to put p. Now that gets me a 0 here. And I need a 0 here, and I need to open down. So I'm going to kind of cheese out in just a little bit to make life easier for us. Make that k, sorry. How does that look? So now really what I'm kind of looking at now is P is going to be the proportion. See how I took this here? P is this is the proportion of things over the carrying capacity. So here, well, I guess it's not, never mind. This all works out good. So notice that P dot equals 0 when P equals 0 and when P equals K. That was what we wanted. And it looks kind of like this. And we put the K in there because we don't know how high this will get. But notice how, like, just thinking about this problem in a realistic way, knowing that this is a parabola, so we know this is a parabola, and so we just create a model. Cool. This is actually called the logistics model. Logistics model of growth. And there is a lot of cool stuff that goes on with this. Kendra knows some of it, I think. And Vivian probably too, and Olivia. Didn't we talk maybe about this in calc just a little bit? Yeah. I think that's where it was, wasn't it? I don't know.
Yeah.
I talk about the thing. I'm not trying to keep a secret from you all. I just like don't want to. I talk about that thing so much. I have no idea where I talked about it. So hey, could you solve this? Because the answer is yes. Would you solve it? Yeah. Leave the K on the right side. Use separation. Oh shit, make this a C. That's not the same K, sorry. That's not the same K as that. That was this, sorry. Yeah, got a little excited there. That shouldn't affect it. Leave the C on the right.
And K?
No, well, the K is gonna have to ride along this stuff. When you do the separation, these two terms are gonna move under the DP. Does that make sense?
Yeah.
Why are we using DT?
Because we're thinking of growth with respect to time. We're thinking of the population changing with respect to time. So maybe, can you elaborate more why it's concerning?
Yeah, I guess I was confused because like the x-axis on that graph is not related to time at all.
No, the time is hidden inside here. So this is a really different way, Daniel, of just thinking about this. It's really just telling me the relationship between the state value and the change value.
Which
So-
is in respect to time. So
Yes, yeah, exactly. So the yeah, I don't know if that helps.
my question is answered.
Oh, for wonder, we're good. Oh, that's great, thank you. Oh, yeah, because we did talk about chaos. You might that partial fractions. I hope you're using partial fractions because I don't know what else you would do. Actually, need partial fractions here. That could be tricky. But you can do it. I know that you can. And it will probably be really hard to solve for P in terms of T for this. So let's just go for like the implicit version that comes out right after integration. Nope. Oop. Need a new kind of D. If you got to here, you did a stellar job getting to here. I'm going to show you why this is pretty raunchy. Ooh, this should be a minus. Woo! Chris, I remember one day back in my office,
Oh, yeah.
I made the same goddamn
Yeah,
mistake.
I remember when
Yeah.
that happened.
It was miserable. Like,
It's such a sneaky little sign change that you just never expect.
it is. But it is there and it makes this change from doable to undoable to doable.
What is the rule again?
It was just that I was doing you do a U substitution here, so we've got, let's pull the 1 over K out in front, we've got 1 over P over K. And actually, I think there's more. I think there should be a, I think this is actually not, I think it's just that. Oh, this might not be too bad. I better do this slowly instead of trying to be a slick jackass. So let's see here. So I'm gonna let U be the denominator,
Yeah.
right? And then du would be negative 1 over K dp. And then dp is going to be du over negative 1 over K. And so when I replace this dp, put this dp into du terms, I get a negative 1 over K out in front.
Yeah.
And then that cancels with this one, but it introduces that negative. Does that make sense?
Yeah.
Cool. Very good. So this is freaking awesome. That is some good shit because this is just, there's no number out in front, which really makes this terrible. difference of logs is the log of the quotients. CT plus D. Do the exponential game, and this becomes P over 1 minus P over K equals some new constant, we'll call it capital D, e to the CT. And now I could solve that for P, and I'm going to. So you might have, I think we've done something like this somewhere in here. Multiply both sides by the denominator. So we get P equals D e to the CT times 1 minus P over K, and then distribute. And so it's going to be D over K e to the CTP. Get all the P stuff to the left, and just factor out a P. So what you're going to get is 1 plus D over K, right there. Yeah, okay, this is happy. This is good shit. And then this is still left over here. Divide by, oh wait, e to the CT. I think that looks good. Yeah, move this over, factor the P out, and then P is finally this. I'm going to make it look a little bit better. Just one more move, 2 more moves. I'm going to multiply by K on the top and the bottom just to get that fraction out, and e to the negative CT, so that I get dk over K times e to the negative CT plus D. Woo. All right. You would get that if you had enough time and like someone rubbing your back, letting you know it's okay, and that you could do it, because I know you can do it. So that's an interesting curve, and if you sketched it out, what you would see is this. You could get out Desmos and change the different values. We're not gonna do this for a specific case. I just really wanted to show you the process, and that you have all sorts of skills you didn't maybe know you had. So, where does that go? So what is the limit of that right side as t goes to infinity? Let's say c is a positive number. So c will be a positive number. What is the limit of that as t goes to infinity? Yes, yeah, good job. So the answer is k. Let's see how that was done. So Lipina looked at this and said, hey, as t goes to infinity, this is 1 over e to the CT, because c is positive. And so that goes to 0. This piece dies as t goes to infinity. So that goes to 0, and you're left with dk over d, and that's just k. So this is also like a sanity check. This shit worked out. So when we're looking at long-term behavior here, now we'll go to p of t and t. So now it's a normal graph. As we head to as positive infinity, we have asymptotic behavior approaching the carrying capacity. So we have this kind of asymptotic behavior there. We have some initial condition that meets this, like right here, this is time 0. We would have this kind of like curvature like that. And then as we moved out this way, you could prove that it approached 0 as you head back that way. So this looks like something you would expect from a population that was growing, but eventually would stop. And Chris, I think this is what you were saying. This is what you were thinking of instead of that phase picture. Yeah. This function is also used in artificial intelligence, in machine learning. This is called a sigmoid function, something like that. It's definitely used in neural networks. So it makes the rounds. Okay, that's all I have for you today. Let's take the last half hour, and I'll come around and help you, or we can work on the web work, or whatever you want to do. When does that web work due? Oh, that sounds stupid. When would you like it due? Just tell me. Never do, never do.
We could do
Is like Wednesday night fine? Thursday seems like a Thursday, is that what you want?
Yeah, just work till midnight tonight, so. I
Okay,
can,
sure. Alright, how about Thursday? I'll go with Thursday, but you have to send me an email
Okay.
that asks for that, please.
Okay.
It doesn't have to be polite, just Thursday web
I'll
work.
just put as many emojis in it as possible.
But I am gonna give some new stuff on Wednesday, so just be warned.
I never ended up doing this too.
Oh, okay, thank you. Great, it's great. I haven't started great. I just made the key out, so we're good to go. Sure. Oh, is it? Oh, I know why. Yeah. When'd you start playing? Too long ago, a lifetime ago.
No, I actually did it like maybe 4 years ago, and it's kind of been on and off since then. I'm not like dedicated.
That's why I didn't touch it, because I knew what would happen.
It can ruin someone's life.
Yeah, I can.
I've seen it first.
Yeah, have you seen the South Park?
Yeah, classic.
It's called A Number of Emotions. And Leroy Jenkins.
And the math one?
Yeah. Oh, yeah, good shit.
It's just being.
Oh, that's just kind of
A question like 2x function is like 2 to the t. That is 2 times e to the t. So that exp function is e to the t.
I better tell everybody.
Okay.
That's a good question, Thomas, or a good observation. Hey friends, when you see
Any T in
this,
there?
when you see this in the web work, it means this.
Yeah.
Just so you know, that's what that means. That's just computerese. Okay.
I would be.
So first we get. Let me get different glasses. I got the wrong. I got the far away ones.
I wish I would have kept on these problems. There. I think that's a good one.
Yes.
That's pretty accurate. There we go. Incorrect. That's great.
Did everybody get my email about my office hours changing too?
Yeah.
Okay.
Alright.
I don't know.
What do you mean?
I did it so long ago.
Here's the deal. I got the integrated factor right. His is the -5.
Oh, number 8. Number 8 is like.
And then you have X, G, Y. That's not X.
Okay. Oh, but so you're interpreting this wrong. That's 9 times e to the t.
Okay, yeah.
That's why. No wonder this was a night.
This is
It's
where
gonna be so much
Yes,
better.
okay.
Oh my god.
Yeah, that's, okay, so that's
Yeah,
what's
that's like
going on.
confirmed,
Good
it is
Lord, he
correct.
works it all the way through.
Okay.
Kudos. This, you're gonna be much happier with this, 'cause
33%.
these things will
So then-
cancel and
Okay,
stuff.
The next part is just.
Does that make more sense?
Yeah.
Okay, cool. Got another one,
It's
sure.
hard to do because then you get
This one.
exponential
Just
5y
y times.
equals 1 over x to the 11th.
Yeah,
And that's what it should be. But then
So-
you do it. Maybe this is
Yeah, I mean,
and then you just do
this
it.
is, you're not the first person to be stumped with this.
I've
Which one is
memorized
this?
this
This
number
is,
by now because I've
number
done it so
9,
many
okay, thanks.
times. This is what I have.
Just plug this equation into the left side. Yeah, like find y prime,
Because it's
add it to y, and whatever comes out is g of t.
times x to the negative 6. Just x to the negative 11.
So you're like building the problem almost. You're kind of making the problem. You've got to start with the
And then
solution,
it
but
says-
yeah, so just compute this left side using that y, and that's what g has to be. And then y at 0 equals y, well, why not? Well, here's your y, when t equals 0, what's the value?
Can't you
No,
try to
not
solve for
quite
y
that,
though?
but-
Yeah, and I did.
Yeah, and I'm guessing you had some of the x over the 5th, right?
Yeah. So then
Yes,
when
but
you
You
what
had
is
c
y not?
times that too? Yeah.
Actually, we know what y is. So what is this at
put
0?
in,
'Cause
oh,
that's
right.
y.
Here, let me just
Putting
copy
it in,
it down.
or-
Let me just copy it down. Let's write down some stuff.
Okay.
Just forget about that.
The
If I gave you this and
sector
said, hey
or-
Vivian, what's y at 0 if this is y? What would you tell me?
Y at 0.
What is y of 0?
Really?
When t is 0, what is
So
y?
then it's just one. I've already tried this problem.
I think you've got yourself really bound up in some idea you
I
have.
have a worse one.
I can tell, because I'm not asking you anything heavy. I'm just saying, look at this, don't think about diff EQ.
I know linear.
When t is 0, what is y of
dy
t?
dx minus
Yes.
equation.
That's
Separable value with the x, y, and then
because it's
exact.
what this
And then
is.
I'm out
That's
there or
zero.
something, is why can't I just
See?
say this? And then I differentiate it.
It'll be whatever, when you plug it into the left side, you get that out. Combine, simplify those two,
Yes.
you'll get it. I'm gonna work one up here real quick.
Okay. You wanna see that too? Which one is this?
Number 9.
Number 9.
Yeah, I have that. I think I tried it earlier.
And I'm gonna work through a problem like number 9. A couple folks, not just right now, but have asked this over the course of that homework. So let's say I've got y prime minus y equals f of t, g, or we'll say g of t, geez. And then y at 0 equals y naught. And I'm given that y is equal to 2 sine of t minus e to the 2, minus e to the 2t. So let's say I'm given this. This is like number 9. You're given the solution. You're actually writing the problem here. This is how I would create a problem for you to do. So I'd say, okay, I want this to be the solution. What does this right-hand side have to be for that to be the case? And what does this y naught have to be for that to be the solution? So this one's pretty easy. Let's start there. This is just replace t with 0 in this thing. So when t equals 0, we get y equals 2 sine of 0 minus e to the 0, so negative 1. So here, y naught would have to be negative 1, because that's the value of this function at 0. Does that make sense on that? So then, to do this left side, I gotta find y prime. So y prime is gonna be 2 cos t minus 2e to the 2t. I'm gonna take this minus the original function. I'm plugging it into the left-hand side. This is an idea that we'll do a lot after break. So let's see, so y is equal to this. And then I subtract, so I get y prime minus y would have to equal 2 cos t minus 2 sine t. And then that becomes a plus, right? So minus just a single e to the 2t. So that's g of t. Really different way of thinking about what's going on here. Nathan, does that help?
Yeah, it just kind of lost you on the last part. Like, how did he get that y prime equals 2 cos?
I just took the derivative of the thing I was given as solution.
Oh, okay.
Yeah. So they give you this y and they want it to be the solution to this. You gotta figure out what the right side needs to be for that. Yes, ma'am. Oh, you got all sorts of stuff. You got a lab set up over here. Oh, sure. Yeah, definitely. Yeah, do you want some like videos and stuff too? Or, okay, would you send me an email to remind me of these things? Yeah. Doing good?
I'm pretty sure I was at some point on the right track.
Ah,
Yeah.
Anthony. Yes,
I feel like you were.
sir.
I was
Oh, shit, this thing is death trap.
Yeah, it's all good.
Agreed.
Disappeared. And sometimes that's just how it
Yes, that was my mind.
is. It not exactly what
Yeah, this is how I did mine. But I was like, I'm trying to form like
Oh,
what do you do Mine's is X,
Mine's is X,
yeah,
full.
long story short, so I just integrated it to a fraction, but
I tried solving it, it's not seeming impossible.
That's because, let's take a look here real quick. So there's something else going on. I think you should be getting e to the negative. I think that's the.
This is,
Okay, there we go. Just to keep us both right. So if you did the right first move, so you got
Oh,
4 over
yeah,
x,
because
y
mine-
equals.
mine was 4x, y prime.
Oh, I
was
see,
16
I see what
so
you're
I took
talking
out
about.
my
You
pilot.
didn't multiply the right side by your integrating factor, that's the problem. So that's right, we get
Yours
this.
is this one.
oh, wait,
When you find that integrating factor based off this,
okay.
which is actually just x
What if you
to the
did
fourth.
the
Yeah, I pointed out when I, okay,
Yes.
when I played that,
That's it.
Yeah, yeah. So it works out
It
nicely,
took me
right?
forever on Saturday, I was so mad.
Oh, that's good, yeah.
Yeah, email me.
Yeah, me too.
Yes.
Is this like some sort of sacred area here?
That's so weird.
Okay,
Oh, it's a T, not an X.
yes,
I know, I get my X's.
Yes.
Switched up all the
Okay.
time, cause I just wanna make X's for everyone.
okay.
I hate when I use T's cause it looks amazing, but like my X is like really speedy, so then when I then we have X plus, and it's all just line. It's not doesn't make any sense. I just,
Oh, I see, so you multiplied through by d, okay, got it.
And then we have like something like integrating of the FD.
So there's a couple problems with it, I like the effort, but this y now has to be viewed as a function of
I'm
t.
plugging into a calculator.
If you're gonna do this, and y is a function of
What is
t.
it?
We just don't
1
know
XY
what it is.
prime.
So when I write this, there's nothing I could do with that integral. I can't compute that, because I don't know why.
Differential equation, I know, right?
That's correct.
That's where we went.
That is, yes, that is where you want. So really, honestly, the only way I know how to do this reasonably, I mean, I know another way, but
I hope for your sake.
What is this?
is to just go through the back door and just work it backwards and figure out, just like, and re-engineer the problem. Does that make sense? Yeah, because there's nothing, so, let's say you wanted to do what you did, let's take a look. And I like this, So if I took a look at this and I didn't know what this was, I have a linear DE, right? So I've got, there's something here, and I can grab
wait,
that,
plug it in,
and
right?
E to the T is my integrating factor. Cause you got a 1 right here, right? So, oh, it's an addition, well, there's still a 1 there though. Yeah. So if I was doing this kind of like we did in general with these problems, I would get my integrating factor is going to be
That's
E
right.
to the
I think you're
integral
just gonna
of
cut your
9.
losses and move on.
So that would just be T, and I multiply both sides by E to the T here, and the left side would become D to T of E to the T y equals the right side E to the T G of T. And then, now we're on the right track, then I integrate both sides.
Please don't be right.
E to the T y equals E to the T G of T dt.
Yeah, see.
And then y is equal to E to the negative T, and I can't bring that inside
There's
here.
no way this is right, like.
E to the negative
No
T, G to the
way.
T, G of T, dt. And so now, Labina, what you're tasked with is figuring out what that G of T needs to
Really
be
weird though.
for that to be the solution. And I think that sounds incredibly hard.
These are linear, right?
It's not fun at all. So the more fun route is just
First order?
plug it into the left side, see what comes out the right, yeah? Does that sound good? Okay. Okay, hi.
This one is just not liking me at all. This, the confirmed the integration factor is x to the negative 5.
Yes.
I did all of this fancy little shenanigans.
Oh,
This is what I get.
wait, Keitra. I think it's -1/11.
Okay, that would make sense because it's
Wait, okay, let's take a look here. So we've got, so you multiply both sides by x to the negative 5. the left side becomes D, just, yeah, can I write some stuff on it, just cause I like to see these steps, intermediate steps, so it's EDT of e to the negative, excuse me, x to the negative fifth. Times y equals x to the negative 11, so I agree with all of that. And then you integrate, that goes to Yep, okay, well, that sounds so good so far. And then y equals, now I'm gonna multiply by x to the fifth. Yeah, I mean,
I think I just got it.
so yeah, I agree with that. Let's see what you're putting in. Chris, did you get a different answer?
And I've done this so many times. And I do the same every time.
That is disturbing.
Yes.
You did get a different answer?
Well, this, I just plugged into another calculator, and this is what it says.
I don't like,
Is-
where's the 11 coming from?
I know, that's what so I'm trying to use substitution, but I don't think that might not be it.
There's, yeah, that's,
Oh, I'm just
well, let's take a look. Let's actually see, let's go backwards. Let's take this solution, which is y equals negative 1/10 x to the negative fifth plus cx to the fifth. And let's see what differential equation it would give us. So let's see, so y prime is gonna be 1/2 x to the negative sixth plus 5c to the fourth. And then, let's see, what was our defeat q right here? So if I take x times this y prime, which is what we got here, right? Take x times that, and then this y prime, what's this spread? So x to the negative 5th plus 5cx to the 5th minus 5 times, let's put it here so we're careful. Is that making sense what I'm doing? Yeah. So then that is going to be 1/2 x to the negative 5th plus 1/2 x to the negative 5th gives me x to the negative 5th. Whoa. Well, maybe still might cancel. Well, wait, where's the 6? There is something. Yeah, that's plus 1, right? Yeah, because it's 1/2 plus 1/2. But then what about this 2 here? So that's, oh, those cancel. These two cancel. So wait, whoa, so something is wrong.
We just got the integration back.
Yes, but we didn't get x to the negative 6, which is what we should have gotten. So what did we do wrong? So, okay, let's check it out. So integrating factor is going to be integral e to the
Look at the ugly thing I got.
yes. That is definitely x to the negative 5th.
Here's the.
Okay, yes, I agree with that so much. I agree with that so much. Yeah, we're doing something weird and wrong though, because this tells us our answer isn't right, not for this problem. And it's making me think that that answer is right, but I don't. Oh wait, Chris has got a slightly different one. He's got equals x to the negative 6, so that's why.
Yeah, I can look into a different calculator this time.
But still, that right side. Oh, I see. I think you didn't divide by x first. Oh, you did, but you didn't do it here. X to the negative 7. Right, because when I take this
Yes.
and I divide through by x, you just didn't do it all the way across.
Okay, sure. I did that in mine.
It's so
I
easy.
just didn't do it right.
So then it is to the 11.
Yes.
And, okay.
There we go. That's why we work together. Okay. Is it not, it doesn't like what we did? Okay, let's take a look. So, 3 and see that works. So that's less bad, right? Okay, so that looks good.
OMG.
Oh, not a way.
We got ski shuttle.
Crazy.
You changed that. Oh, I see that. Yeah, got it.
Are you doing the snow your trip this Sunday?
I know that helps, but I'm
No,
lost
no,
here.
Katie. Yeah, I'm sure because like I'm.
Let's check this part out.
This is actually what, the simple way of doing it.
Oh, that would be, yeah, that's
Good.
alright, sometimes it helps to just even ask about it, right?
Is it either the negative or
So,
Yes, ma'am.
my number 7 gonna be, I'm having a
Okay.
very big number for C, it's like
Okay.
negative 20956.
Okay, so this looks good, I agree with that. So we multiply here by x squared. Plus 8 squared, we get, yeah, so this all looks good. This all looks good. And I agree with that. And then that, that all looks pretty good, Lavina. Oh, wait, so tell me, explain to me why you mean it doesn't work.
I mean, if I put in it,
Careful.
60 minus 4.
perfect, okay.
Oh, you minus.
If I put in the multiplication, it's gonna be
By
4, so x is 0, so that's gonna be 8.
Are you gonna go on any
Yeah, yeah.
metrics this year?
My schedule? Damn, I'm lucky if I get a walk outside.
7
You make a fair point.
divided by, or multiplied by
You see a glimpse of the sun.
This nocturnal.
It's 1 over
That's so
8
good.
squared,
Sounds so
so
great
that
for
goes
you.
on to the next.
That's totally right.
Yeah, right, I got it right, because I got it right.
in the
It's
morning.
on your head and I
When
can't
it's,
do
I
that.
go to bed when it's dark, when I wake up when it's dark, and I do
Okay,
it.
so we're gonna get.
Someone asked me how much I sleep, I said, let me tell you the hours when I don't sleep, and then you can just call me whenever you want.
Okay, you got a lot of.
That's not ideal.
Nope.
So this is.
That too, right? Yeah.
Just straight up no.
I don't think I'm
Unfortunately.
That's
right, you're just right.
Stop by there.
Fair enough.
Squared.
I feel like this might help though.
And
I'm gonna multiply 3 by 8 squared.
I just don't know why there's times.
I think so, they saw, wait, you just
1, 7, 8 to the 10. No, the 7. 7. Equals C. Bye, bye,
Oh
bye.
my god, I did it.
Yes.
Got it?
So C equals 4 times 8 squared minus 178 to the 7.
Oh my god. That's the problem that I have. And this one.
Yeah, I did.
Still the same number.
What is this? What is this?
Okay, so that's just trying to put it into like that whole, thingy, and trying to get the answer of that.
Oh, yeah. So what is, okay, well, let's try this. Let's just enter things in just this way without getting all expanded out like you had there.
Okay, so,
Because if you do a U substitution up here, out of the twos end up on there.
Whoa, your 3, your 2 is way harder than my 2.
What was your two?
My 2.
You.
I was like, you're dumb.
You said one.
This is.
It's kind of nice because those cancel out, but that's it's kind of it.
360 over.
Ignore that. It's wrong anyway.
Here, I'm gonna do it from the board. 'Cause I don't have
Inofficial.
I don't have my paper away.
That's right.
I'm trying to take a photo of this.
Before you erase it.
Or I'll just do it. What is
Yeah.
this?
I guess maybe I should take a picture of that number 9. Oh, that's.
Oh, is that number 9? That's number 9.
That number 9.
I've got this feeling that something went
Beautiful
wrong
math
with your
equation was
equation.
expansion.
Like
Yeah.
you're a real professor.
That's
Oh
why,
my gosh.
that's why I was like, what's
Tried
that?
this,
Yeah,
so many times.
Let me know when you're
my
ready.
goodness.
There's one over here.
Yeah, you're
And
doing
then-
it right.
I know,
Ooh.
that's
I understand. of 1 equals 5 plus 9e.
That.
Y of 1.
Y of one.
Oh, yeah.
And it's nice because when I take the derivative, like when I go to find the integrated vector, it cancels out like the x cubed and 3x squared,
Yeah.
Oh yeah, that looks lovely.
which is really nice.
So you get x cubed as your integrating
Bye-bye.
factor, right? Bye.
I
You should.
I've done this problem many times, and I've lost where I've done my math.
So x cubed is gonna be our integrating factor.
And I'm pretty positive that's what I got. Let's see if I can actually get it. I numbered it somewhere, I hope.
Oh, it's all good, it'll work out.